All right, guys, we're going to come back. We're going to start some additional talking about congruent triangles and going a little further than what we have been doing, okay? So we've been saying all along that if two triangles are congruent, okay, they have to have all six corresponding parts equal, okay? That is, okay, if these two triangles are congruent, if we can make this statement, then this must be true. All these angles, A and X, B and Y, C and Z, and all the corresponding sides, AB, XY, BC, and YZ, and AC, and XZ, they must all be congruent. Now, we've subsequently learned, okay, that there were postulates that avoided us having to show all six parts were congruent. We had the triple S, which said, hey, if all the sides of one triangle are congruent to all the sides of the other, then the two triangles are congruent. We had the side angle side, said if two sides in the included angle of one triangle are congruent to two angles and the two sides in the included angle of another triangle, then the triangles are congruent, okay? And we had the angle side angle, all right? So we've had all these things which, okay, going forward said all we had to do was show some combination of three parts of a triangle congruent to the same combination of three parts of another triangle, and the triangles were in fact congruent, okay? So we have the triple S, okay, we said if all three sides were congruent of one triangle, then with the same corresponding sides of another triangle, triangle were congruent. We had the side angle side, which we all knew, hopefully, and we used that a lot, okay? And we had the angle side angle, right? All of which said, okay, even though these triangles have only three parts, these combination of parts allow us to say the triangles are congruent. And if the triangles are congruent, they're not only congruent by these three parts, they're congruent by the other three parts as well, okay? So that's where we're going to pick up with that stuff from here on. Here's a proof, okay? BD is perpendicular AC and BD bisects angle B, so we knew how to proceed and mark that off as this. Once it was marked off, it looked like we could determine the triangle congruence, in this case by angle side angle, okay? And then we set up the proof. And here again is another example. Mark off the figure. Okay, when the figure was marked off, we could see that looked like we could show triangle congruence by the angle side angle. Okay, and here's a final one, a proof, perpendicular bisector. So we put in the pieces of that for the proof. Okay, and let's go back and look at that proof. Okay, we start off with the perpendicular bisector. With the perpendicular bisector, we conclude AD and DC are equal. Okay, and then uh, from the bisector part, from the perpendicular, we can determine that two angles here at D are equal and they share a common side. This reflects the property, so the triangles are congruent. So, okay, um, so that was everything we've done with showing triangle congruence. Now we're gonna keep doing that, and we're gonna do something in addition. So okay, so we're back. We're looking at what we call corresponding parts of congruent triangles. Okay, if two triangles are congruent by triple S, we have this kind of arrangement. Okay, all the corresponding sides are congruent, and the two triangles are congruent by triple S. Okay, so it took these three parts to show that the triangles were congruent. But okay, just because these three parts are used in showing triangle congruence does not mean that the other three corresponding parts are congruent, mainly the angles. So once the triangles have been shown congruent, then we can show that all the remaining parts of the triangles are congruent if we're asked for, and the reason for corresponding parts of congruent triangles are congruent, okay? So even though we only used the sides here to show the triangles congruent, we concluded that the triangles were congruent, which meant that not only were the sides equal, okay, but the angles are equal as well. So if we're asked to in a proof, we say, oh, we can establish angle A and angle X are equal because corresponding parts of congruent triangles are congruent. Cpctc. Angle B is congruent to angle Y. Cpctc. And angle C is congruent to angle Z. Okay? Now, if two triangles are congruent by SAS, okay, then the pieces that are marked off are congruent, but if those triangles are congruent, and they are by SAS, then not only are these pieces equal, but the other three pieces can be determined to be equal as well by corresponding parts, okay, of congruent triangles which are congruent. Um, so we have, in addition to these three pieces that were used, okay, angle A and angle X going to be equal by corresponding parts of congruent triangles congruent. Angle B and Y also congruent, and side AB and XY are congruent by corresponding parts of congruent triangles are congruent. Okay? Two triangles are congruent by ASA. Okay, so if these pieces are marked off as congruent, then the triangles are congruent by ASA. But what if we wanted to go beyond that? What if we wanted to show that angle um, B and angle R are equal? Well, they are equal as well by corresponding parts of congruent triangles are congruent. Angle B is equal to angle R. Cpctc. CD is equal to SR. Cpctc. Okay, and the other side BD is equal to RT. Corresponding parts of congruent triangles are congruent. Okay, all right. So that's what we have. Okay, whenever we have two triangles congruent, okay, not only are they congruent by the three pieces used to establish the proof, but they're also congruent after we've proven the triangles congruent on the basis of corresponding parts of congruent triangles are congruent. Okay, so we'll look at a couple proofs on that. Okay, you're going to have a couple proofs here. These are exact same proofs that we've looked at before. Okay, all right, but here's what we're saying. Okay, in this proof, we're asking you to show that AC and AD are congruent. You must first show that triangle CBA and triangle DEA are congruent. So you first must show the triangles are congruent. Same thing as we've done before. Once the triangles are shown as congruent, then, okay, this piece can be shown congruent by corresponding parts of congruent triangles, okay? Here we have the perpendicular bisector, okay? But we want to show that angle A and angle C are equal, okay? Angle A and C have nothing to do with the perpendicular bisector. So we determine the left and right triangles are congruent. You should be able to pick that up on the basis of side angle side. Once the triangles are shown congruent, then, okay, corresponding parts of congruent triangles will show angle A and angle C equal, okay? All right, here we have G being the midpoint, okay, which is going to set up the triangles congruent. These are going to pivot into place around point G. Triangles are congruent by side angle side, but we want to go further than that. So once we've shown the triangles are congruent, in this case by side angle side, then we can pick up with what we need to show, mainly in this case, EF congruent to HJ by corresponding parts of congruent triangles being congruent, okay? That's what we're going to do with every one of these, okay? All right, here you're going to prove that you want to show that uh, AB and DE are equal lengths. Well, show that this triangle here on the left and this triangle ACB on the right are congruent. You can show those are congruent by side angle side. Once that's done, use the corresponding parts of congruent triangles being congruent to show AB and DE are congruent, okay? Every one of them is going to be done in the same manner, okay? Every one is going to be done in the same manner. Here, we wanted to show that G is the midpoint of EI. Okay, well, show that the two triangles are congruent first. Show that the two triangles are congruent. based on the parallels, okay, when we're going to pick up alternate interior angles, EI and FH, okay, and we're going to have that EF and IH are equal, so you're going to have angle side angle to show that the triangles are congruent. But now that the triangles are congruent, we can pick up, okay, mainly that EG and GI are going to be congruent. And if they're going to be congruent, then G must be the midpoint. So the additional statements here, okay, uh, since EG and GI are corresponding parts of congruent triangles are congruent, okay, then they are equal, and therefore we can conclude that G is the midpoint of I J, of IE on the basis of definition of midpoint. So that's what you want to do with each and every one of these. You want to go through and uh, work through the proofs just like you did for congruent triangles. But then additionally, you want to make the claim that, okay, if you're trying to show certain thing is true, that is, you must first show that congruent corresponding parts of congruent triangles are congruent. Okay, so that's all we have for that.